Good morning, welcome back. Today I will see the concept of mole and we will solve some small problems, that is multiple choice questions or whatever it is coming in the intermediate board. Uh, Mole, people have slightly the misconception, but the clear definition is mole is the amount of substance that contains as many particles or entities or molecules exactly in C612 isotope. The meaning is C612 is taken as a basis that contains the Avogadro number of molecules, and oxygen, if you take relative to the atomic mass of the carbon C612, oxygen 816 also contains same number of Avogadro number of molecules. That means it is the amount of substance which contains the equal number of molecules or entities or atoms. It should be very clear. And from that, the mass was calculated through mass spectrometer and all these things, and Avogadro number is finally found out. That is 6.023 10 to the power of 23. Based on that, we will see some small problems. The number one problem: how many number of molecules of glucose are present in 540 grams of glucose? First, one should know about the glucose formula. Glucose formula C6H12O6. So, molecular weight equal to 180 points decimals are taken out. So, it is around 180. So, simple answer is 540 grams of glucose is given, and how many number of moles was asked. So now one mole mass is 180 grams, so it is 540 by 180, nothing but 3 moles. Next one, calculate the weight of 0.1 mole of sodium carbonate. Now sodium carbonate weight is to be taken. Sodium carbonate is, sodium is 23, carbon is 12, oxygen is 16. So 2 into 23 plus 12 plus 3 into 16, nothing but 96 grams. So 96 grams is equal to 1 mole. Now he is asking 0.1 mole of sodium carbonate, how much is the weight? So it is nothing but 96 by 10 is equivalent to 9.6 grams. These are short type or multiple type questions on mole and R molecules, Avogadro number related. Number 3. How many molecules of glucose are present in 5.23 grams of glucose? Again, glucose formula is known, C6H12O6, molecular weight is 180. So, we know that 1 mole contains any of the substance 6.023 10 to the power of 23 molecules, that is Avogadro number. That means for the glucose purpose, 180 grams contains 6.023 10 to the power of 23 molecules. Here the given is 5.23 grams and asking the number of molecules. So the simple calculation is 5.23 given mass by the molecular mass 180 into Avogadro number 6.023 10 to the power of 23, nothing but 1.75 into 10 to the power of 22. Very simple. Sometimes asking the molecules, sometimes asking the number of moles, sometimes asking the grams. Anything is same. The same one should know about the molecular mass of the particular compound and Avogadro number. Then calculate the number of moles. Any way you can twist or translate or formulate. Now next question. Calculate the number of molecules present in 1.12 into 10 to the power of minus 7 cc's of gas present at STP. It is slightly next level, but it is the gas. The above the previous people all solids. Now we have taken as a gas. Now only STP one should know about the standard volume. Standard volume at the STP is 22.4 liters. Once if I know, then it is same. Similar again, mole and molecules and all. Now the question is number of molecules present in 1.12 into 10 to the power minus 7 cc. Now STP volume is 22.4 liters, one should know. The second one should know that what is the conversion factor for cc into liter. 1000 cc equal to 1 liter. So this also, if you know, that's all. Problem is solved. So either you convert the liters into cc or cc into liters. So very easy. Whatever the given is 1.12 into 10 to the power minus 7 cc. If I am converting into the liters, that is nothing but 1.12 into 10 to the power minus 10 cc, because 1000 cc equal to 1 liter. So 10 to the power minus 10 liter of gas is given at STP. Now 22.4 liters contains the Avogadro number of molecules, that is 6.023 in 10 to the power 23 molecules. Now I have the gas volume 1.12 into 10 to the power minus 12 liters. So 1.12 into 10 to the power minus 10 into Avogadro number 6.023 in 10 to the power 23 by 22.4 equal to some 3.016 into 10 to the power minus 12 moles. So if you know the small conversions like volume into cc or cc to volume, and that STP volume, that is Avogadro law, 22.4 liters is the standard for the gas at standard temperature and pressure, it can be easily calculated. This is also a bit type, short type or multiple choice questions. Anyway it will be asked, but if you know some 2-3 basics, yes, this mole concept problems can be solved. Then slightly next step, if we go, empirical formulas, converting it to the molecular formula finding. Empirical formula of a compound is CH2O. Its molecular weight is 90. Whereas the empirical formula is CH2O. Just find out the empirical formula weight. Molecular weight by empirical formula weight is nothing but a factor n will come. Then that will multiply with n, gives you the molecular formula. So if the empirical formula of the CH2O is, see whatever the given is, 12 plus 2 plus O, O is 16, 30. The molecular formula is 90. The ratio is 90 by 30, that is n, equal to 3. That means the empirical formula is to be multiplied with 3. So the final molecular formula is C3H6O3. Once again I repeat, empirical formula weight is to be calculated first, then molecular formula by empirical formula will give you the ratio. The ratio is to be multiplied with empirical formula. Here in this case empirical formula is CH2O, whereas empirical formula weight is 30. The given answer is, is molecular formula is 90, so 90 by 30 equal to 3, so ratio is 3, so empirical formula is to be multiplied with the 3, so the molecular formula is C3H6O3. Next level question, calculate the amount of water produced by the combustion of 16 grams of methane. Very simple question. First one should know about the reactants and one should know about the products. Any gas which is in reaction with oxygen means combustion, gives you the, if it is a proper combustion, CO2 and H2O. So methane also same, CH4 is the symbol or formula, CH4 for O2 gives CO2 plus H2O, equation should be balanced. So CH4 plus 2O2 equal to CO2 plus 2H2O. Then only the calculations to be calculated. First, equation should be balanced. That is stoichiometric equation. Stoichiometry itself is a balancing equation. So now CH4 plus 2O2 gives CO2 plus 2H2O. Here H2O also we have taken as a gas. Gas means a steam. So now CH4 molecular weight is 16 grams. 12 plus 4, 16 grams. O2 is not necessary because it was not asked unnecessarily, time waste. So here 1 mole of methane is giving 2 moles of water. 1 mole equal to 16 grams. So question is 16 grams of methane is combustion and how much is the water produced? 2 moles of water is produced. 1 mole equal to 18 grams. So 2 mole equal to 36 grams. Very simple. So like this, these are the small multiple choice questions or short answer questions. Next we will see the equivalent weight. Just introduction we will see today. The next we will proceed for the equivalent weights of the different because slightly it is more interesting and slightly one has to understand carefully. So we know the dollar, we know the rupee, we know the pound. So one we know the equivalent to the other. So simple is $1 equal to 80 rupees and 1 pound equal to 100 rupees. So that is equivalent. So in the chemicals also the equivalent weight is normally used in the calculations. Suppose oxygen weight is nothing but 8. Hydrogen equivalent weight equal to 1. Sodium hydroxide equivalent weight is 40. Means sodium and oxygen and hydrogen, it is all added. Sodium is 23, oxygen is 16 and hydrogen is 1. 16 plus 1 plus 40, 23. 23 plus 16 plus 1, 40. HCl, H is 1, Cl is 35.5, total is 36.5. These are the equivalents. But why we are telling like this equivalent weight is molecular weight? It is not same. Second one is it changes with the situation. Definition is the definition of the equivalent weight is the sum of the examples. So it will not change by the strong alkaline medium, it will be changing, and in acidic medium the equivalent weight is also changing. So equivalent weight is changing. So but a general rough idea is equivalent weight is the atomic weight by the valency of that particular element. Suppose equivalent weight of sodium equal to atomic weight of sodium by valency of sodium. Equivalent of oxygen equal to atomic weight of oxygen by valency of oxygen. So atomic weight by valency is nothing but equivalent weight. That is the definition. Atomic weight by valency of that particular element equal to equivalent weight of the element. So thank you.